Hey class, this is 5.1. This is just an example problems. You already have a 5.1 ed puzzle, called 5.1 types of bonds. And I would just like to give my own instruction on, I'm not sure why this is not, there we go. I'd like to give my own instruction on the 3 different types of bonds so you guys can see specifically how it's working here. Let me line that back up. Come on. Boy, this is... Okay, good enough. Great. So here's the deal. We have 3 different types of bonds. The one that he talks about first is called ionic. The ionic bond is between a metal and a non-metal. Now, what's a metal and what's a non-metal? You guys know from before that we have metals here, non-metals here. That includes also hydrogen. So hydrogen would be considered a non-metal. And when we put a metal with a non-metal, the metals tend to have positive, here, let me just give you just a quick, because we're going to get into this shortly. Metals tend to make cations, which means positive ions, and non-metals tend to make anions, which are negative ions. Okay, which means that they have more electrons. We've talked about all this stuff. Number of protons, number of electrons, and blah, blah, blah. So we'll get more into that then. So here's the deal. We have ionic compounds where a metal joins with a nonmetal, such as sodium that we have here and chloride over here. And when one electron transfers from sodium to chlorine, we have an ionic bond. We call it a transfer. It doesn't actually completely move over, but that's how we like to think of it because it makes it nice and easy. Now, there's a difference between that and covalent bonds. Covalent bonds are between nonmetals and nonmetals. That means I can have something like carbon monoxide. Carbon monoxide is my example. Now, these two, the carbon and the oxygen, have electrons on the outside, and they end up sharing those electrons, specific electrons, so that both of them can be more stable. That's what a covalent bond is, when you have a nonmetal and a nonmetal sharing electrons. So this is sharing electrons. That's an E minus, there we go. And this one is transferring electrons. Okay, that's just it. That's the whole deal right there, ionic and covalent. Now there's a third one. Actually, there's 100 different types of bonds, but the top 3, the ones that we like to teach in school and not, for a chemistry degree, are ionic, covalent, and then of course metallic. And you guys know what metallic is because you've seen these kinds of bonds where we have a metal attached to another metal, and there's other ways that this happens. It happens by, again, sharing, we call it like a sea of electrons. That's an SEA, not SEE. So SEA of electrons, as in you have the atoms, the metallic atoms, atoms of metals, and then on top of those atoms are electrons that can float back and forth uninhibited, and that's how electricity happens. So that's part of our metallic bonding, where we have a metal atom bonded to another metal atom. Okay. So moving on, those are the 3 different types. I'm not going to go over with you stability of a chemical system. Is that bond breaking or bond forming? I want to remind you of BARF. This is something he talks about. Mr. Palermo does in his ed puzzle. If bonds are breaking, energy is absorbing, and energy is releasing if bonds are forming. Okay, that's how I want you to think of it. Bonds breaking, for the B, are absorbing energy. So if we are absorbing energy, that is an endothermic situation, and that is bond breaking. If we are releasing energy, that is an exothermic process, and that means bonds forming. Okay, so that's how I want you to think of it. You can fill in the rest here by simply watching and taking notes from the ed puzzle because it explains it very clearly. Moving on. This part here, all you have to do is take a look. We have symbols. Remember, the symbols are capital letter, lowercase letter, capital letter, lowercase letter. That is for one element. If you find this element on the left-hand side of the periodic table, that means it's a metal. So this is a metal. And Cl, if you find that on the other side, that means it's a nonmetal. And what we have then is an ionic bond. Okay, if I look here and I look for C, now if you have two capital letters, that means capital C and capital O. And don't worry about the numbers. The numbers don't mean much to us right now. We're just identifying whether we have metals or nonmetals. That's the only thing we're concerned about, metals or nonmetals. And C, because there's no smaller letter, like this would be cobalt, but this is just carbon. And carbon is on the right-hand side, and so is oxygen. So that means we have a nonmetal and nonmetal, which means covalent bond. Nonmetal and nonmetal. So you need to look at your periodic table and determine whether you have a metal or a nonmetal for each one of these. Here again we have one letter, that's an N, and then another letter O. Those are both nonmetals. So we're talking about a covalent bond. Okay, that's how I want you to do each one of these. What else is there here? So this is talking about, let me just give you like an idea. Come on. I'm waiting for my, okay. It's not going to work for me, is it? Okay. There we go. Really, really slow. So here I'm doing examples where you can see that I have Li2O. So this is Li is a metal and O is a nonmetal. So that means, there we go, and we're back. And metal and nonmetal means ionic. The type of molecule is ionic. Type of bond is ionic. We'll talk a little bit more about both ionic and covalent, although you really don't have to worry about that. I'm not as concerned. There's one or two parts down below. I'll show that. So this is a little confusing. Conducts electricity. Conducts electricity as in it does not conduct electricity, or it conducts it as a solid, which is the S in parentheses, or a liquid, which is the L in parentheses, or aqueous solution, which is the AQ. Aqueous solution means that I took Li2O and added water to it, like Kool-Aid. I take the Kool-Aid powder and put it in the water, and that gives me an aqueous solution. It just means something dissolved in water. So if it's dissolved in water and conducts electricity, that's what an ionic compound does. Okay, it conducts electricity by being dissolved in water. Let's take a look at another one. I circled this one before you saw me erase it. This right here is 2 fluorine atoms. If it's 2 fluorine atoms, that's nonmetal and nonmetal because fluorine is on the right-hand side, which means that what I have then is a covalent compound. Okay, this is what we call a molecular compound. So if it's covalent by bond type, which is what this is here, that means I have a molecular compound. Okay, not to confuse you, but that's what it means. My spelling is awful with this thing here. There we go. Molecular compound. If we have a molecular compound, it does not conduct electricity. Okay, there is no, it does not conduct electricity. Notice for F here, I have just iron. Iron means iron atoms connected to iron atoms. And if they're both metallic, then I have a metallic type of molecule. Okay, which means that my bond type is metallic, which means that it does conduct electricity, and we know iron is a solid at room temperature, so it conducts electricity there. Okay, I guess it conducts electricity if you melt it, but that's not how we think of iron. We think of iron as conducting electricity, obviously through the solid. I think that's pretty much it. Indicate which type of substance is described in each. So again, these are just listening to the Ed puzzle. Can conduct electricity in a solid or liquid phases. You would have to pick between a covalent, ionic, or metallic. And you should be able to do that after taking the notes from 5.1. All right, good luck. When we come back, we'll go over 5.1 so you get to see what it actually says, what the answers are. Thank you. Nice work.